wanted to make something go pop? Not with a balloon, but with science. It's honestly one of my favorite things to do. Today, we are going to become amazing scientists. We'll use something you might find in your kitchen cupboard. It's a fizzy vitamin C tablet. These tablets aren't just good for you, but they can also create a super exciting chemical reaction. This experiment is all about mixing things together to see what happens. We're going to mix a tablet with water inside a special tube. Are you ready to make a rocket? Let's get our science goggles on and prepare for some popping good fun. First, let's gather our supplies for this fantastic experiment. You'll need a fizzy vitamin C tablet. You'll also need a plastic film canister. These are small tubes with lids that pop on tightly. If you can't find one, a small, clean plastic tube with a snap-on lid will also work. Of course, we'll need some water. That's it. Just 3 simple things can create an amazing scientific discovery right in your own home or classroom. We're going to explore how these simple items can teach us big science words and ideas. It's amazing how everyday objects can unlock the secrets of chemistry. Before we start mixing, let's talk about what we are going to learn. This isn't just about making a loud noise. We are going to learn about chemistry. Chemistry is the science of what things are made of and how they change when you mix them together. We'll see a solid tablet turn into a bubbly gas. We'll also learn why some changes are forever, while others can be undone. Science is all about asking questions and finding the answers through experiments. So get your curious brain ready to ask lots of questions. Why does it fizz? What makes the lid fly off? So what do you think will happen? A good scientist always makes a prediction. A prediction is just a smart guess based on what you already know. Do you think the tablet will just disappear in the water? Or do you think it will make a lot of bubbles? What about that lid? Do you think it will stay on, or will it shoot into the air like a rocket? Think about it for a moment and make your best guess. There are no right or wrong answers when you're making a prediction. It's all part of the scientific adventure. Let's find out together. Let's dive into the amazing science. When you drop the vitamin C tablet into the water, something incredible begins to happen. You'll see lots of tiny bubbles fizzing up to the surface. This is called an effervescent reaction. That's a brilliant science word. It means that a solid is reacting with a liquid to create a gas. The tablet starts to dissolve, which means it breaks down into smaller and smaller pieces until it seems to disappear into the water, mixing with it completely. But it hasn't really vanished. It's just changed its form in a very exciting and bubbly way. So, what is making all those bubbles? The fizzy tablet contains 2 special ingredients, an acid, like citric acid, and a base, like sodium bicarbonate. When they're dry inside the tablet, they don't do anything. But as soon as they get wet, they start to react with each other. This reaction creates a gas called carbon dioxide. This is the very same gas that makes the bubbles in your fizzy drinks. As the tablet dissolves, it releases more and more of this carbon dioxide gas into the water. All those bubbles are looking for a way to escape. Now, imagine all of this happening inside our little plastic tube with the lid snapped on tight. The carbon dioxide gas bubbles are filling up the water. Soon there's no more room in the water, so the gas starts to fill the empty space at the top of the tube. But more and more gas is still being made. The gas particles are whizzing around, bumping into each other and pushing against the walls of the tube. This creates pressure. The pressure builds up more and more, pushing harder and harder against the sides and, most importantly, against the lid. Pop! Suddenly, the pressure becomes too strong for the lid to hold on. The lid is pushed off with a loud pop and flies into the air. This is an amazing example of an irreversible change. The tablet has reacted with the water to make a new substance, the carbon dioxide gas. You can't get the tablet back to its solid form just by waiting for the water to dry. It has changed forever. This is different from a reversible change, like melting an ice cube. You can always freeze the water to get the ice cube back again. Every great scientist knows that experiments are all about being curious and careful. One of the most important jobs of a scientist is to observe. This means watching, listening, and noticing everything that happens. When you do your experiment, what do you see? Watch the bubbles forming. What do you hear? Listen for the fizzing sound and the final pop. You can even feel the tube. Does it feel different after the reaction starts? Write down everything you observe. These notes are called your results, and they are super important for understanding what happened in your experiment. Scientists also love to measure things. Measuring makes our observations even more accurate. For our experiment, we can measure how much water we use. Does using more water make the pop happen faster or slower? We can also measure time. Use a stopwatch to see how long it takes for the lid to pop off after you add the tablet. Recording these measurements helps us to see patterns. Maybe you'll discover that using warm water makes the reaction happen much quicker than using cold water. That's a brilliant discovery. Now let's talk about a very important science word: variable. A variable is any part of the experiment that you can change to see what happens. In our pop rocket experiment, the amount of water is a variable. The temperature of the water is another variable. Even the tablet itself can be a variable. What if you break the tablet into small pieces first? Do you think that will change how quickly the lid pops off? When you change one variable, you should try to keep everything else the same. This way, you know that any difference in your results is because of the one thing you changed. It's also really important to be safe when you are doing any science experiment. Always ask a grown-up to help you. For this experiment, make sure you wear safety goggles to protect your eyes from any splashes or from the flying lid. And never, ever put the lid on and point the tube at your face or anyone else's face. Point it upwards and away from people, pets, and breakable things. Science is amazing and fun, and following safety rules makes sure it stays that way for everyone. Always tidy up after your experiment is finished too. Did you know that vitamin C is super important for your body? It's also known as ascorbic acid. Our bodies use it to help us heal if we get a cut, to keep our gums healthy, and to help our immune system fight off sniffles and colds. It's a bit like a superhero vitamin for our body's defense team. We can't make our own vitamin C, so we need to get it from the food we eat. Lots of yummy fruits and vegetables are packed with it, like oranges, strawberries, kiwi fruit, peppers, and broccoli. So eating your 5 a day is a great way to stay healthy. Now you know the science. It's time to experiment like a real chemist. What could you change to see if it affects your pop rocket? Here's an idea. Try changing the variable of the water temperature. Ask a grown-up to help you get some cold water and some warm water, not hot. Put the same amount of water in 2 different canisters. Add a whole tablet to each at the same time. Which one pops first? Make a prediction, then try it out. You could record your results in a table to compare them. This is how scientists make new discoveries. What if you change the tablet? Try breaking one tablet into 4 small pieces. Put the pieces into the water and quickly put the lid on. Time how long it takes to pop. Is it faster or slower than using a whole tablet? Why do you think that is? Crushing the tablet creates a bigger surface area. This means more of the tablet can touch the water at once, which might make the reaction happen much faster. You are in control of the experiment. Every change you make can lead to a new and exciting question to investigate. So, what have we learned? We've seen how mixing a solid and a liquid can create a gas. We've learned that this builds up pressure and can make things go pop. We know this is an irreversible change. We have also learned how to think like scientists by predicting, observing, and measuring. Here are some final questions to think about. What would happen if you didn't put the lid on at all? What if you used a different fizzy drink instead of water? Keep asking questions, keep experimenting safely, and keep having fun with science.